Okay, so let's move on to the last question of this paper, which is question number 10. Okay, this is question number 10, and it's something from algebra. Okay, so in question 10 we can see an equation k minus 1 times x to the power 6 plus 4x cubed plus k minus 4 equals to 0. Okay, this is an equation. Part A is asking find the exact solutions to the given equation for k equals to 4.5. If the value for k is 4.5, then what would be the equation? 4.5 minus 1, it is what? 3.5. So 3.5 x to the power 6 plus 4x cubed plus 4.5 minus 4, this is half. Okay, so 3.5, it is basically 7 over 2x to the power 6 plus 4x cubed plus half equals to 0, right? So multiply both sides by 2 so that the denominator gets cancelled. 7x to the power 6 plus 8x cubed plus 1, this is equals to 0. Okay, now it seems to be like a cubic equation, but we have to use the concept of solving quadratic equation to get the solution. Okay, because if you see attentively, the format this cubic equation has gotten, it's actually a quadratic format. How? We can convert it to quadratic format. 7x cubed whole squared plus 8x cubed plus 1 equals to 0. So if you consider a equals to x cubed, then we can deduce, we can simplify the index, the power. Okay, how? 7a squared plus 8a plus 1 equals to 0. We simplified the power. Okay, now we can easily apply the middle term factorization, isn't it? 7a 7a squared plus 7a plus a plus 1. So 7a into 7a plus a plus 1 equals to 0. So we can take 7a common, so a plus 1, and from there we can take 1 common. Okay, we get 0. Okay, so either a equals to -1 or a equals to -1 over 7. Now retrieve the the value of a. Okay, because we supposed earlier a equals to x cubed, yeah. So if you retrieve the value, you will get x cubed equals to -1 or x cubed equals to -1 over 7. Okay, so either x equals to -1 or x equals to -1 over cubic root of 7, and that's the answer for part A. Okay, so we got exact solutions. One is -1 and the one is -1 over cube root of 7. Done. Part B, find the set of possible values of k for which the given equation has no roots. Okay, we need to find out the set of values, okay, the range of values for k such that this equation will have no roots. So if this equation, if we want that this equation should not have any roots, then we need to compare it with a quadratic equation, because as we did part A, we could compare the format with a quadratic format, right? So like as that we will approach here. Okay, for part B we can write the equation like k minus 1 x to the power 6, right? So in place of x to the power 6 we can write x cubed whole square. Okay, then plus 4x cubed plus 4x cubed plus k minus 1 equals to 0, right? Plus k minus 4. K minus 4, isn't it? K minus 4. Yes, it is k minus 4 equals to 0. So, like as before, we can consider a equals to x cube. Okay. So what you will get here, you will get a quadratic equation: a square plus 4a plus k minus 4 equals to 0. And if we want to have no roots, then b square minus 4ac must be less than 0. Okay, so b squared, b is what? 4 here, 4 squared minus 4 times a is basically the coefficient of a squared, so k minus 1 times c is k minus 4. This is equals to 0. Sorry, this needs to be less than 0. Okay, so 16 minus 4 times k minus 1 times k minus 4, that is basically k square minus 4k minus k, so negative 5k plus 4, it's less than 0. Okay, we got a quadratic inequality. So 16 minus 4k squared, multiply the bracket, plus 20k minus 16 should be less than 0. Okay, now take all the terms to the right side so that we can have positive 4k squared. Okay, so 4k squared, negative 20k, negative 16 plus 16 cancels out. So, and now the whole term is on the right hand side, which is greater than side, so greater than 0. Okay, now you just need to solve this quadratic inequality. So for solving quadratic inequality, we know that for quadratic inequality we know that we need to find the critical point first, right? At critical points, why we need critical points? Because critical points are the values or the points with respect to which we find out the regions for the inequality. Okay, with respect to the critical points, we find or we set the regions of the inequality. Okay, so at the critical points equals to 0, we consider equals to 0, so you can take 4k common, so that would be k minus 5 equals to 0. So either k equals to 0 or k equals to 5. Okay, now we got the critical points. Now we need to find out the set of values. Okay, so let me draw the equation, draw the curve for this equation: 4k square negative 20k. The coefficient of k square is positive, so it must have a minimum turning point, and it will pass through 0 and the point 5, x equals to 5, k equals to 5. This is the k axis. Okay, instead of x, it's now k. So the curve will be a bit like this. Okay, now we got the critical points. This is 0 and this is 5. Okay, now check the inequality. If you see the inequality, it says greater than. So to support this inequality, we need to choose the values of k which will support this inequality. Okay, we need to choose the values of k which will support this inequality, and this inequality says the values of k should be such that the value of this equation 4k square negative 20k, it remains greater than 0. So greater than 0 is basically the part above the x-axis, because at this part it's what? Greater than 0. Okay, so these at this region, the value of the curve the y value of the curve it's greater than 0, and the k values for this region will support this inequality. Okay, so the k values are these ones, these k values. Okay, so k here greater than 5, and here it is what, k less than 0. For these k values, the y value of this equation will be greater than 0. That means these k values will support the inequality. Okay, so set of values it is k less than 0 or k greater than 5. Okay, so the set of values we found here, k less than 0 or k greater than 5, and that's the answer for part B of the last question, that is question number 10 from the May 2025 Pure Mathematics 1 paper. And that's the end of this playlist, and I would definitely invite you to watch our next videos. We will try to upload more videos now for GCE A levels, also for international A level, and also we will try to focus on some higher level concepts likely to be university first year concepts, and also we would invite you to our crash courses that the admission is currently going on. We got many students from different countries around the world and also from the UK. So we are highly encouraging you to join our crash courses. These are really effective, and what we do, we try to explain everything from the basics. If you see our videos, you can understand, like, though these are exam questions, but still I always try to explain from the basics, so that even one who don't have the idea or the basic idea can still understand what I'm doing or what I'm solving. So the crash courses also, though these are crash courses, but still we cover them up from the basics. Okay, so these crash courses will be very effective for your exams. Okay, so that's all for this playlist, and have a good day. Fine.